Dr. Mark McGill. Now, Mark, have you got slides to share as well? Yep. Well, there we go. Off we pop. Working fine.
Yep, hopefully.
Enormously jealous. There we have it. Mark is, as with Julie, a colleague in computer science. And the history of projects that I'm aware of Mark being involved in include ones with Logitech, with those kind of keyboards and interaction type questions that you get with things like that, but also looking at issues to do with privacy and the recording snap glasses and various things like that. Highly relevant work to the things that we will want to consider. So I'm delighted that Mark's been able to join us, and I'll hand it over to you, Mark.
Okay, thanks, Neil. So a little bit of background first. As he was saying, yep, I'm a lecturer from University of Glasgow as well, in the same department as Julie, and actually very similar areas of research in truth. So I also work on the intersection of HCI and mixed or extended reality, and myself and Julie collaborate on a few of the projects that I'll be mentioning as well. So I'll just briefly give a tour of the kinds of projects that I worked on so far. And where we've been trying to push the tech towards. So perhaps my earliest project was as a child. I was given a Viewmaster as a kid. This is probably my first exposure to virtual reality until the Oculus Rift came along. I've been creating augmented virtuality or mixed reality experiences in VR for a while. So here, this was our early work in 2015, where we used pass-through cameras to, for example, selectively incorporate physical keyboards into the user's VR view. So that was an early and somewhat crude attempt at some of the things that Julie was showing you there. They've now found their way into commercial products. Here we used the same approaches to create early bystander awareness systems, where we could show co-located others that were proximate to the VR user and integrate them into the VR scene. The idea here being that we wouldn't necessarily break your immersion in VR, but we could give you some awareness of what was going on in reality. I've also worked on telepresence social VR. So this project here was using Kinect V2 depth cameras to create shared social VR experiences. So this one was a VR cinema where I could look to my left and see the at a distance person. Similarly, they could see me captured through depth camera. And here, a shared and synchronous telepresence 360-degree video experience. I've also looked at location-based auditory mixed reality. So this, as you can see here, is a pair of Bose frames that Julie was showing earlier, strapped to a camera as I was walking around the West End. And we were using these headsets to orally augment the soundscape of individuals as they walked around. So one of the really interesting things about these headsets is that they are effectively acoustically transparent audio headwear with head orientation tracking. So we are intermixing the sounds of reality with the virtual sounds that are generated. And sounds delivered via such headsets might lead us to question whether the sound we're hearing is real or virtual. For example, we had participants that confused virtual birdsong as the real thing in the right context. And I've even been looking more recently at passenger usage of XR devices. This is part of ERC Viajero, which is a project that Julie is also on. This is looking at how we can use these headsets to overcome motion sickness and sensory conflict and enable immersive entertainment and productivity whilst traveling. So I've had a reasonable amount of experience with basically building weird experiences with these technologies, typically exploring usability issues or novel interactions with them. And today's talk will cover two topics that I've been focusing on recently. So firstly, why we think these devices will see ubiquitous adoption, with a particular focus on our recent XR productivity research, which is extolling the benefits of these headsets for creating ergonomic or usable virtual workspaces. And then also the privacy challenges and risks posed by widespread uptake and everyday or all-day usage of XR devices, and in particular the risks posed to the bystanders of those devices. So people that are within the sight or sound of the device's cameras or microphones. And fundamentally, I think XR and spatial computing will enable users to alter augment, or indeed entirely replace reality. And I think that offers significant benefits to how we're going to work, how we're going to communicate, how we're going to collaborate in the future, how we're even entertained. And the challenge here, I think, is in facilitating the best that these devices has to offer, whilst mitigating against the risks that it poses to us as users, bystanders, society as a whole. So, at the risk of repeating what others have said so far, XR tech is continually advancing in terms of fidelity, form factor, comfort, and so on. And each advance takes us closer to these devices being everyday consumer realities. For virtual reality, recent examples I find quite interesting include the Vive Flow on the right here and the Lynx headset on the left. And these are VR headsets that are targeting more compact, wearable form factors that are targeting, mobile use, casual use, portable use. And for augmented reality, one eventual endpoint here is everyday wearable devices, so resembling something like a standard pair of glasses that are worn throughout the day. And the idea here is that these glasses could effectively interleave themselves into our lives. So on the left here, we can see the Nreal AR headset, where all the rendering is done on the glasses, and then that kind of puck you see in the person's pocket is where all the computation is. And then on the right, we can see Facebook, or now Meta's, Project Aria glasses. And that's an example of packing augmented reality related sensing into a glasses like form factor. So they're kind of working toward getting this complete AR package. In that one, they don't have the optics, they just have the sensors. And the eventual existence, adoption, and prevalence of such devices will lead to a significant change in personal computing. And I've always liked this quote here saying, we won't be able to opt out from wearing AR glasses in 2035 any more than we can opt out of owning smartphones today. So there's this anticipation, at least, that the AR glasses or some similar headset will supplement and eventually supplant existing displays and devices in favor of rendering virtual spatial content around the user. And in time, there's this expectation that AR and VR will effectively converge towards truly mixed reality devices. So for example, you can have occlusive VR headsets with cameras that can use reality pass-through, as Julie was talking about, to create AR-like experiences. Or you can have AR headsets with occlusive shielding that can selectively or entirely block out the light of reality, effectively creating VR experiences here. Now, this may be preaching to the converted a bit, but there's still often a reticence to fully believe that these displays and headsets will see truly meaningful usage or adoption. But as Neil, Julie, and Steve have illustrated so far, the collective might of all the major tech companies is bent towards overcoming the engineering and the technical challenges to bring everyday XR into reality. And we're already there to an extent with VR. I think, as you can see with the Quest 2 and Julie's projects, these are headsets that can be deployed in public spaces and used in those contexts. And AR isn't far behind, at least in terms of capability, if not quite the form factor you'd want. So headset-based VR, I'm sure you're all aware, most popular these days for gaming, exercise more recently, training, simulations, whilst AR spatial computing has a myriad of applications. So it changes how we view and interact with the world around us. So again, another clip of the Microsoft HoloLens here, rendering exocentric, world-locked spatial content in the real world. And it supports things like direct hand-tracked touch interactions, just in the same way that the Quest 2 does. And such devices will change how we collaborate and communicate, both at a distance. So for example, through immersive virtual events using systems like Engage. I imagine some of you have probably attended such events in the last year or so with the pandemic. And even in person or in blended or hybrid contexts. So this video here is a concept video from Microsoft Mesh with mixed VR and AR collaboration around a shared virtual artifact. It doesn't appear to be playing. So you can see here on the left, at least briefly, there's the avatar of a VR user. On the right, you have this depth captured imagery of an AR user, and they're all collaborating over this shared table. But as a computing scientist and as someone that spends most of my life staring at an array of monitors, the most compelling reason for me to adopt these headsets is really productivity. And in particular, how I can have yet more monitors on which to work, much like Steve's concept of virtual technology. So this was, at least at one point, my desk at work pre-COVID. And here I have multiple large displays that are egocentrically oriented toward me, but exocentrically positioned, so locked in the real world, as well as multiple devices and peripherals that are all here to, in theory, at least help me to multitask more effectively. However, there are a variety of issues with these kinds of working environments. So firstly, this presents a physical barrier to the world. So it cuts me off from others, this won't disappear, I can't easily remove it. These displays are not easily adjustable or adaptable to a specific task. You're sorely limited to how many physical displays you can have here, and they are ergonomically problematic because they are difficult to position or orient. There's no adaptation over time or based on my seating posture. If I'm leaning forward or if I'm leaning back, they remain fixed in the same space. And fundamentally, they don't travel. They don't translate to mobile usage. I have to resort to using the laptop in the corner when I'm out and about. However, we're approaching a point where we will become less reliant on physical displays. So we now have, XR headsets that are sufficiently capable of rendering virtual displays that are both wide and have legible text for the first time. And there have been numerous examples of this over the past few years, predominantly in VR. So, big screen is a particularly popular app these days. Virtual desktop is as well. Meta's Infinite Office concept, which they showed, I can't remember now, probably a year ago or something like that, which is now, elements of this are basically effectively built into the Quest 2, as Julie was showing you. And in AR, multiple projects have used devices like the Microsoft HoloLens to render virtual displays and content in mixed reality. For better or worse in this particular case, I leave that to be determined. And the benefits of virtual displays that I think are particularly key are that fundamentally we can manipulate the virtual displays or apps in ways that are difficult to impossible to do with physical displays. So the question we were asking was, well, what manipulations are worthwhile? So are we targeting usability, ergonomics, efficiency, or some other metrics for success here? And there are a number of factors which we can trivially manipulate with a virtual display. For example, its size, its shape, its orientation. And if we have mixed reality headsets, these displays don't even need to physically exist. Instead, they could just be rendered virtually by my headset alongside existing displays. So you can see some examples here where research has supplemented existing laptops or desktop displays with additional virtual content oriented around them. And even the number of displays or display elements that we have available can be manipulated here. So there are no longer any meaningful restrictions on what we each choose to call our workspace. And this gives us a lot of freedom to effectively redesign and improve upon the status quo. So our early work here focused on the ergonomic benefits in particular. So this is a video clip from a paper we published looking at applying counter-rotational movements to wide wraparound display spaces. So this was a fully usable VR productivity environment, complete with a Logitech tracked keyboard. That was an early prototype of the one that Julie showed you, and a touchpad, mirrored Windows desktops. Effectively, it was usable. People could use this to use any Windows apps and interact with them. And our approach here was simple, but quite effective. So if you looked toward the virtual display to your left or right, we would counter-rotate these displays in the opposite direction. So effectively having the amount of head or neck movement required to view that display. And you can see this in action here. So I look left, I look right, the display slots into place, and the workspace counter-rotates to require this reduced head or neck movement. And this simple manipulation of the position of these virtual displays made wide workspaces more comfortable and more accessible to users, and it effectively allowed their use in a more ergonomic envelope of neck movement. So virtual displays give us an opportunity not just to present more content, but to present it in ways that better take into account ergonomics and the ability or range of motion of an individual, and adapt to changes in our context or posture or position or any other situational or permanent impairments. And crucially, the benefits of such virtual workspaces are mobile too, so they can travel with you. So in this study, we put people into a number of different VR travel environments. This was part of our Viajero project. So we were replicating real world context in VR and exploring how users might want to design virtual workspaces that could enable productivity whilst traveling. So on trains, planes, cars and subways. Now, I'm just going to show a few examples of the most extreme conditions here, where we asked users to figure out what their 5-display virtual workspace would be. But we've already seen some quite different strategies here between those that use these virtual displays as a barrier to occlude other passengers and prioritize their comfort and usability, to those that try to adapt the virtual displays to the social context they're in. So here, for example, you can see that the user has left this gap in the middle where the passengers opposite them are. This avoids occluding the passengers, and it also avoids the risk of being perceived to be staring at those passengers when you're actually staring at the virtual display that is aligned next to them. Here in this train environment, this person found it acceptable and preferable to orient their display space vertically instead of horizontally, given the freedom of the AR device and a feeling that they kind of owned that space in front of them on the table. Whereas here again, this person tried to avoid occluding the other passengers and effectively worked around the constraints of the social context. So in the future, we'd expect a transition away from physical displays toward virtual productivity. And we've already identified clear benefits in terms of ergonomics and mobility, your workspace able to travel with you and adapt to the physical environment you're in. But the benefits don't necessarily stop there. So this obsolescence of some physical displays should potentially lower energy usage in offices, for example. And in terms of the work environment, the ability to augment or supplant reality with virtual content, maybe that could potentially create a more calming or enjoyable office, particularly potentially beneficial for open plan offices or when you're working at home. You can have a virtual window to your home garden, or have your work-related augmentations in your home office disappear at the end of the day when you turn the headset off or you switch context in your AR glasses. However, if we assume that AR headsets and spatial computing will eventually supplant smartphones, laptops, monitors, and so on, then there's also the significant potential negative implications here in terms of privacy due to the requisite sensing that these devices use. So let's start by assuming that XR devices will see ubiquitous uptake and become part of everyday life. What are the risks posed to the individual users of XR, the bystanders to those XR devices, and society overall? Now, it's hard to map out the risks here, but we can look at existing risks and uses of similar technology to extrapolate potential risks in the future. And I'll go over a few that I think are quite representative of both the utility and danger of these kinds of headsets. And you may find it heartening or disheartening that I think many of these risks were raised previously by Steve. Maybe that means they are particularly pertinent. So in terms of risks of XR headsets to the users of those devices, these devices have a significant influence over our perception of reality. So they're able to alter, influence, entirely overwrite this. And this introduces specific risks for VR and AR. So for virtual reality, consider perceptual realism or super realism. So every aspect of the XR sensory experience is becoming more realistic in terms of high quality visuals and behavioral realism of virtual humans. the visual realism and plausibility of the virtual environments, the plausibility of the virtual events that are occurring in them in terms of the physics, for example, and the seamless merging of virtual content and mixed reality. And this poses obvious but often quite ill understood risks when applied to, for example, risky violent or sexual media, regarding the potential psychological or longitudinal impact of engaging with such content. In terms of altering our perception of reality, for augmented reality in particular, consider behavior nudging, or the ability of a given device or app to alter your personal sensescape to influence your attitudes towards others or brands, or the use of advertising, as Steve was talking about. And at the extreme, those familiar with Black Mirror will recognize this concept as an example of entirely blocking out the visual perception of those around you, something that one day inevitably will be technically feasible. And in time, we will come to rely on these headsets to supplement our cognition and our memory. So this is often termed augmented intelligence. And there's a chance here that we will become maybe overly dependent on them to assist us, which could lead to reduced working memory, for example. Maybe Julie will be unable to navigate in new tourist environments because she's so dependent on her Bose frames. And in terms of privacy, in wearing these headsets and agreeing to their platform terms of service, we will potentially be engaging in a consensual erosion of our physical and mental privacy. And this is as a result, as I was saying earlier, of what we were terming kind of requisite XR sensing. So cameras, microphones, IMUs, physiological sensing, gaze tracking, and so on. So access to this data would allow for both immediate comprehension of our daily life and also longitudinal understanding of the user's behaviors, their likes, their dislikes, termed biometric psychography. So for example, this image on the right here was Meta discussing how their Project Aria glasses were in various ways superior to personal LiDAR, autonomous vehicles, and satellites for some reason in terms of their capacity to sense and capture the world around us. So it's an impressive image, but also a fairly harrowing one if you consider the implications of it. And any anticipated veil of anonymity will likely be lifted given such capability. So even basic behavioral biometric data, such as positional tracking data, arm length, and so on, can be fused to arrive at a reliable means of uniquely tracking an individual. And once this data leaves our devices, it's hard to have any form of agency or control over what happens to it. So depending on local laws, data can be retained, processed, and fused to unintended and unanticipated outcomes with varying degrees of accuracy if you look into things like algorithmic bias, for example. But then there are also significant risks that are posed to bystanders to XR users. So that's just the general public around you when you're the one wearing the AR headset. So for example, consider volumetric capture and appropriation of your appearance. So depth sensors in the cameras make it trivial to capture people, places, objects, environments to a very reasonable fidelity right now. And we as bystanders have little to no say on how this captured imagery is used or repurposed. That same body tracking that can also be used for augmented appearance. So I imagine many of you use Snapchat or Instagram filters or TikTok. So our capacity to alter our appearances perceived by other AR users will undoubtedly be used to enhance things like expression of identity or augment fashion, but how will we avoid non-consensual augmentations of our appearance by others? And then there's augmented perception or personal surveillance, which Steve touched on as well. So XR devices can effectively, selectively enhance our senses through augmented perception. So this is a powerful feature for overcoming temporary or situational or permanent impairments, but also potentially open to abuse in terms of eavesdropping or recording. So effectively going beyond the natural limits of human memory and sensory reach. And in conjunction, one or more XR devices in a space have the capacity to effectively surveil that space completely, supporting persistent, ubiquitous tracking, recording, volumetric capture. And this has been suggested to potentially bring about a global panopticon society of constant surveillance in public or semi-public spaces. In this dystopia, the possibility of being recorded looms over every walk in the park, every conversation in a bar, and indeed everything you do near other people. And in this way, we can see XR as amplifying existing risks inherent to Internet of Things or smart camera infrastructure. Now, that's not to say that there aren't safeguards in place here, and I'll go through a few highlights for existing protections. So currently, we're largely reliant on existing privacy law and voluntary restraint from market leaders here. So EU GDPR or UK GDPR, thanks to Brexit for us, governs how personal data can be captured, stored, and processed. And it protects to an extent against abuses of personal data to an extent, but largely remains untested when confronted with the challenges posed by XR devices. And if you go beyond the UK and the EU, it gets trickier. So in the United States, for example, there is this patchwork of national and state level legislation around personally identifiable information and clear gaps around the processing activities that you can enact through these devices. And fundamentally, any legal protections are vulnerable to lobbying. So legislation can change for the better, but can also change for the worse over time. Then as a society, our reactions toward the adoption and acceptance of technology can steer the conversation and potentially influence things like legislation. So these social norms are yet to fully emerge because we just aren't at the point of that ubiquitous usage of XR technology. As you'd see from the examples that Julie was showing of the VR usage in the bar, for example. However, we have seen at least one clear rejection event in AR previously. So Neil was talking about Google Glass, which was piloted many years ago now. And whilst the manual for Google Glass explicitly said, don't be creepy or rude, people didn't understand when and in what way the device was being used around them, or when they were potentially being recorded, or for users, how they were expected to use it in a way that was socially acceptable. And this led to Glass users being branded glass holes, and probably contributed to a fairly major degree to that version of Glass being taken off the market. There are also voluntary guidelines and recommendations of practice that developers in particular can follow. However, these are less common with kind of emergent technology. So, for example, manufacturers of headsets have typically voluntarily instigated limits in terms of things like camera access on some devices in an attempt to head off misuse at the cost of developer functionality. So the Quest 2, for example, you can use pass-through mode to show what's happening in reality, but you can't actually get the imagery for pass-through mode to manipulate that in any way. That's blocked off from you as a developer. And there are some organizations that are working towards these community guidelines, so XRSI, IEEE, for example. However, generally, there's a lack of consensus here, especially compared to other fields like AI ethics or explainable AI initiatives. So, there's a gap here, I think. And as we start to consider the user and bystander experience of these devices, there becomes scope to consider things like privacy enhancing technology or PETs integrated into their very form or function. So for example, Privacy here looked at the integration of a highly visible shutter so that bystanders could be assured the device was no longer active because the shutter would cover up the camera. And there's a lot of options for PETs here, and these might involve hardware or software mitigations that reduce the possibility of risks or increase awareness of risks. But actually for solutions like this, given that we're moving toward sixed off positionally tracked headsets, these headsets are fundamentally reliant on having a camera there to give them that capability to track their position in the world. So actually, shutter solutions maybe don't take into account the needs of these actual devices. And then, we're computing scientists, so we get closer to low-level security engineering things. As we get closer to the operating system and the underlying hardware of the platform we're using, there's more scope to instigate privacy-enhancing technologies that are effectively mandatory or more difficult to circumvent. So a basic example here is looking at smartphone permissions. So these mechanisms provide awareness of how a user's device is using the sensors that are attached to it, what applications are capturing camera footage, for example. And these permission architectures typically provide ways to withdraw consent regarding that permission for a particular application. So in the future, we might imagine that there are similar mechanisms applied to XR, enabling awareness and consent for all those concerned, both users and bystanders. So very quickly, at least, there are a variety of routes by which we can potentially safeguard users and bystanders here, but my view is that current safeguards are largely either insufficient, untested, or frankly vulnerable right now, especially if we see the kinds of adoption of XR technology that we anticipate. And generally, my belief is that there needs to be more and concerted effort to work towards XR devices that support both user and bystander privacy by default before we reach the point of that ubiquitous uptake. So it's very easy to turn a blind eye to the risks I've talked about, given the advantages that these headsets have to offer. But if we do so, we may find that we, as a society, sleepwalk into this consensual erosion of privacy in our haste to, use the latest Apple or Google or Meta XR device in our everyday lives. And on that note, that's me, hopefully roughly on time.